Hello everyone, Mike Levin, May 9th, 2018, around 8 a.m. Just heading out from my secret exit from Irby, and I'm gonna walk to the ferry this morning. I think one of the things that has been missing lately has been the morning time, and I hear a rooster, so I'm going to change my route a little bit so we can maybe see the rooster at the FDNY dock. Yeah, thinking through my day's work in the morning is useful. So if you don't picture it in here, it's not going to happen out there. Bam, you don't have to buy any self-help books now. Yeah. Without getting too wacky about it, there are two worlds, because our senses work through induction. Our five senses only suggest to us what might be out there. And these cameras we're using to record a version of it to play back for ourselves later is modeled on the way our senses work. So we're getting a very selective and human-centric view of what's going on around us, which has very little to do with the totality of what's going on around us. Now, it might have to do with the importance of what's going on around us, which, you know, I could go on so many directions with these videos, because I love to talk about the really fundamental stuff. You know, what Elon Musk might call the first principles, and math people might call axioms, and philosophers might call what do they call them? I don't know. Stuff is built up from these, you know, fundamental truths, but let's just call them givens, right? There's not a lot given in this world, because you got to figure so much of it out for yourself. But you know, one of the things that is given is that stuff happens. Experience is a thing. It's quite difficult to deny that we are all, you know, thinking, and you know, already there's divisions being drawn. We're into the binary world, because what kind of animals are thinking and what kind aren't. We are thinking, self-aware, world-shaping beings, right? You know, what are we doing that makes us different from the animals? Every single thing that is brought up, tool making, oh no, chimpanzees use sticks and termite mounds. Language, no, there's generationally transmitted languages among bonobos and stuff, the rain dances. And tons of animals, actually, animals that weigh tons, out class us in all kinds of communications techniques, like ultra low frequencies that can travel through the oceans. Just merely, you know, being able to submerge to those depths. And you know, there's all kinds of variations in capabilities. And what we call human, the human experience, a class of creatures such as ourselves who have a certain way of experiencing the world, is only one. And you know, things like the Bible, that all the beasts are here to serve us, all that kind of stuff has served to increase that anthropomorphic viewpoint that all things are like humans, and we read that into everything. However, maybe all things are like jellyfish or crystals. Who knows what the fundamental principles are? But we have something called thought that has evolved. And you know, reading James Gleick's information book on the tail of that Quantum Mechanics for the Befuddled, and now with Mindsight, another book that I found that I have in this read-along Kindle Audible format, which is just spectacular, I gotta tell you. It activates different learning centers in your brain. Some people like to learn by reading, and a lot of people claim that reading is one of the best ways of learning, because you are reproducing the actual program that was in the author's head, in as far as the author could express it through instruments and their craft. We'll get to that later. Maybe tools, instruments, language, and craft could be the subject of this this video, because what I really need to resolve at this point is everything is difficult and everything takes work. When someone gives you a set of givens, the first thing that you do is look at what they're saying about the world from those givens. Is something doing something? Where does that energy come from? If you don't pay for it, and is it interacting with things? Well, then where does the energy for the interaction come from? Because it takes energy to interact. There was this thing called Maxwell's Demon back in, I guess, the early part of the 19th century, up until like, for about a 50-year run. There was this presumption that if you had hot on one side, cold on the other, divided by a chamber, the only division between the chamber being a trap door that could be opened and closed selectively upon the will of the creature in the middle, who could observe the molecules and just let the active hot ones pass through and not let the inactive ones pass through. So whenever a moving particle came through the trap to the trap door, you open it, pass through, close it, and in that way you are unstirring the pot. You are separating the hot from the cold. You're doing the impossible, because, you know, of course we now know that a couple of things. First, living creature there, living creatures take energy. Its ability to think takes energy. Everything it does is has to be part of one of these systems. So the demon, Maxwell's demon, doesn't work for free. And then it's watching things happen. Well, that implies interaction, the observer paradox, that photons have to bounce off of the things you're watching, reflect back to some sensory equipment, and you need to, you know, make observations based on the sampling that bounces back. So, you know, the idea that anything is gotten for free. Long-term storage in the cloud, for example. What, you think Amazon's going to stop billing you for that S3 storage ever, and it just somehow becomes free and part of who you are? No. Everything has a cost, and everything has an accounting, and everything has a balancing out. Whether it balances out at far time distances apart or not is, you know, one of those things that makes things look like free energy today. Things, you know, what pays for everything? The sun. Ultimately, the photons streaming down from the sun get converted into all the forms of energy that are adding life organizing, you know, properties to the surface of our planet. We are the product of there being sunlight. I think I'll walk the back way here to not be in the road. Here in Staten Island, one of the first things I realized is that this commute, three-legged commute, train, ferry, train, was just driving me, you know, insane. And so what I decided is that I'd always try and wake up really early and walk at least one of the legs. Here's a bunch of people on scooters, and I've actually been thinking about the possibility of getting myself a scooter, or maybe even one of those motorized e-scooters. And you know, you walk with it almost like you'd walk with a cane in your hands, but when you get outside, it turns into an L-shaped motorized scooter. I see them more and more. It's a natural outgrowth of, you know, battery technology improving. Again, the sun pays for everything, and Elon Musk sees this in all his things he's doing with, you know, Tesla. And electricity is probably just a much more efficient, pure electricity, not converted into chemical, or perhaps hydrogen chemical for recovery to energy as fuel cell. So you can't get rid of burning fuel, but at least the output is water vapor with fuel cell. So burning fuel is still going to be a thing, hopefully less fossil fuels, but where you can't burn fuel, just pure battery technology is going to be constantly improving, and that transforms transportation, communication, all kinds of things. Autonomous robots become viable. Add to them just some modest ability to self-repair, to keep themselves running, make them pay for their energy off of the sun, and suddenly you've got robots with much, much, much longer lifespans than human. That's one of the simple hacks, life hacks, waiting to happen Now that all this stuff is actually kind of sort of simple, the programming you can kind of sort of mostly do in Python, which can kind of sort of mostly tie together every system out there that you'll need this for interaction, you know, computer vision, mobility, machine learning. So yeah, professionally I should be going towards machine learning. It would just be too perfect. Mike Levin, SEO, you know, ML SEO, machine learning SEO, but not exactly ready for that. As I expressed in a prior video, you know, I still am getting down some of those basics that I should have gotten down when I was like 12 years old. And this is why I'm so keen in particular about making sure Addie understands the principles behind coding, which I'm always infusing into her life. You know, I'll talk about first in, first out, you know, on the elevators, if there's a door at the other side of the elevator, otherwise, otherwise it's first in, last out. So, you know, all the different queuing concepts, concepts of, you know, sequencing and timing, those are all so critical to programming, because not all programming, as you know, is making some interactive thing come alive and have infinitely variable behavior. It's also programmed to just sequence things for playback in an experiential way, which is always very important because storytelling always remains at the top of the hierarchy of things that are important to unravel the mysteries of the universe and always make a living for yourself, right? So if you can tell a good story, you can talk your way into a job. If you can tell a good story, you can convey a concept which is almost inhumanly expressible. Thought experiments of Albert Einstein, perfect example. It's just storytelling. Yet the whole concept of the relative universe, oh man. And you know what? It's interesting because, you know, Albert Einstein is one of those guys who would let his head float around in these wholly abstract places and disconnect it from the physical world that we know. He would always try and reconcile it with the physical world, but he never was bound by his real world observations. That's how he could guess at the existence of things before they were discovered, like time dilation. Nikola Tesla, on the other hand, a contemporary of Einstein, someone who actually read Einstein's, you know, theories of relativity, you know, actually criticized it as being foo-foo, as being, you know, wonderful, you know, stuff that doesn't answer the real questions, dressed up as something that does answer the real questions. He used some crazy metaphor about a, you know, a beggar in royal clothing that everyone follows because he looks like the king. And, you know, there's certain truth to that because Einstein spent the last 30 years of his life chasing, you know, unified theory and never achieved it. And, you know, insisted God doesn't play dice with the universe, right as the, you know, real world experimentation was showing us, no, it seems like he or she or it does. I hate the awkwardness of our language. That's a whole nother video I could do about the predisposing of our language, and I'm making sure Addie is keenly aware of it. And I've started the discussion with her that I became aware of from James Gleick's The Information book, that language is a lot more flexible than the purists, the static control freaks would have you think. You think of all this properness as the Queen's English or proper Victorian English, such as it were. Now, the Oxford English Dictionary, which started the whole lexicography thing, is now taking the side that there is no right. If some word is in a certain context, a certain use, and it can be cited, that is a valid use of the word because it's being used that way. It takes the very Tesla approach of, look, there, it's a thing, let's label it. Now, this creates label propagation, infinite. It went from about 60,000 words at, like, I guess the 90s to these days, which is several million words. So an exponential increase in the number of words that are considered, you know, truthy. Anyway, that leads to sort of a contest of people, you know, trying to get new words into there. Like, you know, I think the book, the information book points out that codependency was lobbied for by its, you know, book's creator. And words are always just sort of seeping into common everyday use. And so long as they are, and it's citable, bam, in the Oxford English Dictionary. And that's very different from the way it used to be. And I want to make sure Addie understands that we are going back to the days when, you know, everyone understood and accepted language as a growing, changing thing. It's only with the advent of printing. It's almost like I'm repeating the book. I got to stop here and get to my work, my planning my day. I've got about halfway to go. So let's dive into it. I created a wonderful micro framework, very micro, that just adapts a command syntax from the GSpread API, a Python package and index or PyPy package called GSpread, which does very much what the old GData API did, much more complex. It simplified it to very Excel-like terminology of rows and columns and updates and inserts. And but I'm taking that already simplified GSpread interface and simplifying it one more step to what you would call a blit. People from the old Amiga or Atari days might be familiar with this because our computers had dedicated coprocessors that did blitting, and blitting was moving a rectangular area of memory around on the screen. Add a little bit of masking to that and you have sprites that seem to move around the screen independently of any other processing that's going on the machine. And that's what makes a lot of these video games, or made a lot of those video games back in those days when CPU cycles were precious, seem so impossibly fast compared to their Apple II and IBM PC counterparts of the day that did not have blit or blitter chips. So blitting is moving this rectangular region around in memory, maybe between two different memory systems, CPU memory and video memory, so that the CPU could just change one little number, but over here on the video memory side, lots of numbers change. You're shifting the complexity around, so the CPU has to do very little so that the GPU gets a chance to do what its hardware is optimized to allow it to do quickly. So you just shove a task off of CPU and onto GPU, and your whole system improvement becomes quicker, more magical, more fluid. One of those things about the Amiga that made it so love-worthy. That kind of stuff has been totally reproduced in all of modern stuff. You know, everything has a GPU these days, basically, even a Raspberry Pi. That's part of what made it so popular when Broadcom contributed as a blob, as a compiled digital executable, a video driver that allowed them to use the Broadcom hardware. So it's been open sourced since, and that again was another big move, but this just goes to show that the simplification and the shoving around of the move to dedicated subparts is a valuable thing because it puts the complexity where it belongs and generally takes it off of your hands. My Lightwork framework has done that with all this blitting between Google Sheets and Python Pandas library. Think about that. Rectangular region in Google Sheets, it's in Python Pandas, which is like having an in-memory version of Microsoft Excel. All of its power, maybe times 10, and none of its brittleness in macros or brittleness in embedded VB script or VBA or whatever. And none of its dependency on Microsoft or having a site point server set up in order to bring it as services. You know, it's like there's this gigantic tangle that you just don't have to live with if you just step back and say, I'm going to do all my Excel like work in Pandas under Python, maybe in Jupyter Notebook, and make it really easy. And that's the bandwagon that scientists across the world are jumping onto in order to alleviate the crisis of accountability that swept through their field not many years ago, where a full third of all scientific research was unreproducible as far as the data processing that they drew the conclusions from, that was published, even given the same data sets. So, you know, there's a whole sub-story there about this having been a solved problem in academia if you're willing to pay $1,000 or $2,000 license for MATLAB or Matplotlib. There's a bunch of Mathematica. There's a whole bunch out there that were for this. But the concept of notebooks emerged, and Jupyter Notebook, originally IPython Notebook, sort of did the open source thing that is done, what Linux did to Unix, IPython did to, let's say, Mathematica. And has since evolved so that it runs in the web browser as opposed to just a command line console, given a very pretty user interface. And because it's web-based and everyone can do web stuff, right? You can now do Python because you can feel like you're running Python in the web browser. But in the back, it's actually powered by a full-fledged Python dedicated virtual machine, which is essentially the Python reference specification, the CPython, Guido van Rossum's master version. So all the code you write can be lifted up out of Jupyter Notebook generally, and with very minimal adjustments dropped into a .py file, which lives very readily on a Linux system being invoked or called or constantly run, made sure it's running by systemd, which is the Linux System Manager, the modern one. It sort of replaced a few other things like bash files and cron. I highly recommend it. It's something that people used to the old school way in Linux are going to maybe poo-poo because writing start, stop, init.d bash files is dear to their heart, but not mine. So I embrace systemd wholeheartedly and keep my Python.py file running 24/7, because every 5 seconds the Linux OS check says, are you running? If not, reruns it. That thing it's rerunning can be a constantly running script, so it has no reason to exit, invoking something like the schedule module, again out of Python, packaging index, PyPy, pip install schedule. So, you know, the stuff I've been talking about so far has some, you know, custom bits. So any machine you install Anaconda onto has it. But if you're doing this on some sort of headless cloud server, like a Amazon EC2 AMI instance, or I guess, you would have to do, I guess, pip install pandas. Pip install pandas will get almost all of the dependencies, and so long as the whole dependency toolchain can be built. So you might sometimes have to do a pip install, I forget, system tools, common, system common. It's, maybe I'll put it in the video description. But you need the ability to compile code with the GNU compiler. You don't need to understand all of that. You just need to have it on your machine before you do pip install pandas. It might even install that and then try and install the compiler tool so that it can do the compiler. Things get very meta and very powerful. Okay, so back to my system, because I'm here at the ferry and I got to wrap it up quick. All systems take work. Nothing is free. And it's all just a question of whose budget it's coming out of and where you push complexity around to. My game over the past week or so has been pushing as much complexity as I can into out of config files. Config files had to be simple and Pythonic and pandonic. It had to be, you know, it had to look like standard Stack Overflow examples of Python pandas code. I wanted everything that was blitting, that was using my already simplified API, to do a blit maneuver to pull data out of G-Sheets, push it into pandas, manipulations, pull it out of pandas and back into G sheet, well, that place where I said manipulations, I could be inventing all sorts of crazy language that people would have to learn to use my system, or I can just make it look exactly like Python Panda's copy-paste examples you will find endlessly on the internet. I decided for that later one. Now that means that I'm using mostly just vanilla Python in config files. And if you think about that, it implies I'm writing a whole application or program every time I need some dashboard report in Google Sheets. I am not. The rest of that statement, separate video. The reason why something that looks so simple can do so much is because I am only exposing the very tiny part I have to, so that you can do the customizations you need to get the results that you want. Very abstract stuff, pushing around complexity. So anyway, I am here at the ferry, and this is where I wrap up. So I'm off to actually implement this system that allows even more flexibility, a config file, variable behavior per config file, yet in a way that shoves the complexity onto a config tab in the spreadsheet. That's pretty much it. Thanks for joining me. Hope to see you again soon. And don't forget to pip install Pipulate. Follow me at MikLevin at Twitter, MikLevin. Subscribe to me here on YouTube, and see you later.